we've gotten to chapter 29. All right. So what are we asked to do? What are we asked to do? They said number one said in an electrolysis experiment, the cathode of mass 5G is found to weigh 5.01 G after the current of 5 amps flows for 5 seconds. What is the electrochemical equivalent of the deposited substance? All right. So first of all, we look for the mass change first. So number one, we look for the change in mass first. All right. Look for the change in mass. Current is already there. Current is 5, and the time is 50. That's 50 seconds. So this equals to the last weight, that's 0.01, 5.01. We remove 5, which you will now get what? You now get what as the answer? 0.01. That's what you get. So this is your mass. This is your M. The formula to solve this for electrochemical equivalent, that's this Z will be equal to 1. M, that's this M, this one, M all over IT, that is current over what? Time. All right. So solve. This is it. All right. We are going to number 2 straight away. Number 2 says almost same thing. In a copper plating, a current of 0.5 amps is allowed for cathode area of 100 cm square. If this current is maintained constantly for 100 minutes, the thickness of the copper deposited will be approximately, we are looking for the copper deposited. The electrochemical equivalent of copper is 0.003 gram, all right, per Celsius. Density of copper is 104 gram per cm cube. All right, let's go. So let's take down things we are seeing as usual. Things we are seeing are what? Current. Current is what? 0.5. That's current. We're also having time. Time is 100 minutes, but this 100 minutes will now be multiplied by what? 60 to get what? 6,000 seconds. That's what we use. We don't use minutes here. So 6,000 seconds. Okay. All right, 6,000 seconds. That's what we use there. Let's go. Then the next one is let's take our equivalent, our copper equivalent for copper. So equivalent for copper is what? Our electrochemical equivalent of copper is what? 0.0003 G. All right. Then I think the next one we are supposed to take is our density. So let's talk density P. Density is what? 10.4 G. Sorry, 104. So then this is 104 G. Then finally area. Area is 100 cm cube. All right. Area is 100 cm cube. So the first thing we are looking for, the first thing we are doing on this, is step 1. Step 1 is to find M, to find the mass, and M is equals to Z I T. All right. So when you look for M now, so just look for M. Good. Now the next That's the velocity. We'll look for V. We'll look for the density. All right. We'll look for the density. That's step 2. So step 2, we're looking for the volume of copper. So volume of copper will be equals to mass. That's the mass you got here. Mass over density. And this is your density. This is your density. Don't forget. So mass over density. All right. All right. So if you've gotten mass over density, you've gotten that's your V. That is your V. So you've gotten V. All right. So what we're looking for now will be the thickness. The thickness, that's the step 3 and the last, because that's where we are looking for the thickness, how thick it is. So the thickness, what we're going to do is for thickness, volume, that's you've gotten volume from those things we solved down there. Volume is equal to what? Area times thickness. All right. Therefore, thickness will be equals to what? Volume over area. Normally, our volume, you solve that. Area is 100 cm cube. So that is that. And once you get your answer, that's for thickness, your answer, you change it from cm to mm. All right, change it from cm to mm and you get your final answer. All right, thank you.